And thanks all for joining. My name's Tom Harris. I'm a solutions architect at NetApp. My key focus is on DevOps, which is sometimes a bit contentious coming from an IT vendor. You know, we can't sell you DevOps, right? It's a culture, it's a practice, it's a methodology. But what I like to think it as is that I focus on open source integration, how I can integrate open source projects with our portfolio and allow you to consume our portfolio seamlessly without even having to touch our storage systems ultimately, you know. So hands up here, who's actually heard of NetApp before? Oh, cool, okay. And does anyone have NetApp in their environment currently? And keep your hands up if you're using the Ansible modules. One. Okay, cool. So we need to get that message out there a little bit more then, maybe. So, I mean, yeah, for those who don't know, I'll do a very brief overview. So NetApp are a 27-year-old company, originally doing NFS storage systems. Obviously, further down the line, we integrated block storage into that for a unified system. And really, sort of, we've moved on with the times now. Our operating system can be deployed in all of the major cloud providers. And obviously we still sell hardware on-premise that is available on-premise with the same storage system on that. So it really allows for a single API across all of those different infrastructures. So when it sits in AWS, our storage system sits in AWS, it'll consume AWS resources underneath, but then all the goodness of our data management services around that as well. So that's enough of the vendor pitch now anyway. Let's get on to Ansible and why we have chosen Ansible. I imagine a lot of this probably resonates with you pretty well, and I'm probably preaching to the converted already, maybe, anyway. And that first good reason is no agents required. That works well for us. We don't have to push any agents out to our storage systems. Interestingly enough, I was speaking to a guy who worked for Puppet, and said to him, "How do you push your agents out?" And he said, "Oh, we use Ansible quite a lot of the time," which I found quite interesting. So, yeah. Modules only. Again, we don't need to interact with a server in the middle or anything like that. We can directly address the system through the modules. And the framework for developing modules is quite simple, ultimately. Works on Python, and it's quite easy for us to develop those to work with our systems. Procedural as opposed to declarative. For a storage system, using a declarative framework where you're just stating what the world should look like doesn't always work too well. You know, you might start trying to create a LUN before the volume's actually created, which causes issues when trying to map that LUN if the volume doesn't exist. So procedural works really well. We can create the volume, create the LUN, create the network, go and map that LUN, rather than a declarative approach that will try to do all those things at once. And I found with declarative tools against our system, which we do provide integrations with, you find you can run it once and it brings out a state that is desirable, and the next time you run it, it doesn't work. But Ansible, for us, I found that it works well every single time. So that's good. Idempotent, you know, if you're trying to create a volume and the volume already exists, it's just returning back okay. We're not trying to create the same volume again, which is good. And I find like if you're trying to address the system using Python, for example, a lot of people will try to build idempotency within their Python scripts, which then you're just starting to creating your own configuration management system. So you may as well just use Ansible, right? The focus has been on, because we've had such a high demand from customers really as well over the past year. I've heard it so many times, Ansible. So you know we've started developing modules that really encompass full coverage on our storage systems, so you don't really need to interact with any of our tools. Ultimately, you're just interacting directly with the API. So, and time is money, right? I see some customers, when they get a storage system on the ground in the data center, it may take them a couple of weeks to actually get to the point where they're provisioning storage or supplying storage to their internal consumers. This isn't always down to the complexity of the storage system, but sometimes around sort of technical governance, you know, things need to be verified. And if you're doing these things manually, it's ultimately a manual process to verify some of those things sometimes. With Ansible, you know, the script is there to say, say, what this is going to do, and it's repeatable. So every single storage system that's shipped into the data center, the compliance teams are usually more happier that it's standardized, and they just need the output from Ansible to say that it's worked and it's made the required changes. Looking a bit at our relationship, so we are only one of 8 certified module vendors, which we're quite proud of. Obviously that means we have quite a rigorous process with Red Hat to ensure that our modules are up to the Red Hat standards, basically. So that makes our customers more happy. And if you look at the storage modules on the Red Hat website, there's 178 in total, and we represent nearly 3/4 of them with 128 modules. So yeah, we're the most fully fledged storage and data management vendor out there in terms of Ansible integration, which is good for me. Since 2.6, we're actually been released with the Ansible release, so no need to download the modules separately and address them that way. So support is actually provided by they're fully supported by us as a vendor, but we provide the support for a Slack channel, which is pretty interesting, and it actually works a lot better than standard support methods, I find, as well, because the developers of the modules actually haunt the Slack channel, and the fact that you can talk directly to a developer about a problem that you may have, or an issue that you're facing that you can't understand, is a lot better than talking to a first-line support engineer who ultimately doesn't know the product as well. If you talk to a developer, they made it right. So enough of the slides. I'm going to go through a couple of demos now. These are going to be live, so hopefully we're all good. So the first demo is going to be just configuring a storage system from the ground up. This would be as if you racked it and stacked it in a data center, just assigned it an IP address for the management gateway, essentially, and done nothing else. Alternatively, deployed it in AWS and done nothing else to set it up. So that's sort of the day 0 setup, and then sort of it encompasses a bit of the day 1 operations as well going forward. But you'll see that. But configuring storage systems isn't that exciting, even I find it exciting, but it's not that exciting to most people. So I thought I'd do something a little bit more sexy. So I'm going to migrate an application between with persistent storage between one Kubernetes cluster to another. So I'm leveraging a few technologies here. So that's Kubernetes. This equally applies to OpenShift. In hindsight, I probably should have done it in OpenShift. I'm at a Red Hat sponsored event, but you'll get you'll understand it. And then NetApp as the underlying storage system, and also we have a storage provisioner that works with Kubernetes and OpenShift as well. So using them 2 technologies, and then from an Ansible point of view, I'll be using the NetApp modules and also the Kubernetes module, and really Ansible to tie it all together. So just run through, just to visualise it a bit. I showed it to one of my colleagues the other day, and he said, you need to show them what you're actually doing first. So what I'm doing is creating an application with a persistent storage requirement. You create a persistent volume claim from Kubernetes. It talks to Trident, which is our storage provisioner, and then it automatically creates a volume on the NetApp storage system. So you can consume storage from Kubernetes ultimately using Kubernetes native tools. Now, one of the issues I've seen my customers have with Kubernetes is the fact that, the premise of it is that you can have some large cluster of resource, of compute and RAM, and you don't need to have sort of failover between clusters. In reality, most enterprises need that, for compliance reasons, and just, a safety net, essentially. So if you've got a second cluster, yes, you can go and create another application within that cluster because you're ultimately just pulling a Docker image from a registry. But migrating the storage is a completely different ball game ultimately. I've seen people trying to sort of write in through the front end of the container and then create enough volume underneath, which isn't ideal. So Trident gives the ability to actually import that volume. It's not a native feature of Kubernetes really, but it's driven by Trident, and then you can attach it into the Kubernetes cluster. And obviously we're at the Ansible Meetup, so this is all going to be driven by Ansible. As Mark described earlier, Ansible is the glue, which I really like. Doing all these commands manually might take me 40 minutes to actually import that volume, bring up the application. As you'll see using Ansible, just literally a single YAML file. So probably show that. Well, I was going to show that at the end, but I'll show it now. NetApp.io. It's got loads of demos and other information about what we do around DevOps, so check that out if you wish. All right, let's get into the demos. Right, so first off, I'll just show you what our modules look like and how they're presented ultimately. So the first thing you'll notice up here probably is that they're actually calling to local host. We don't execute over SSH. We're going over HTTPS or HTTP by default, which is why I've got HTTPS true. And then we can do certificate validation if you've got your own certificates, obviously, which I don't have on this system. If you're familiar with NetApp, most of this stuff will probably be familiar with yourselves. If not, we just sort of create a volume, saying whether it be present or absent, and then referencing a storage pool, which we call an aggregate, and then a size. So, pretty simple. I probably don't need to run that, but in most enterprises, you're going to have hundreds, if not thousands of volumes. Using these 16 lines of code over and over again is obviously not very desirable, and it can get quite unwieldy. So obviously, I've written a role for this, which is here. So, you could probably put all of these different tasks for the different storage objects in a single main.yaml. I've just done an import task because I like to play around with it and test different things. So if we look at that, create the storage volume again, obviously I've just put a loop in there, and then I've got a with items loop for my volumes, which most of you guys would have seen this before. So this is what this looks like in a variables file. So a single variables file that describes my infrastructure, so aggregates of storage pools, storage virtual machines to isolate tenants ultimately and workloads, logical interfaces for networking, and then volumes. That's presented quite nice and neatly there. And to be honest, when my customers see this who haven't seen Ansible before, this can look like sort of an Excel document that they have hanging around to actually describe their infrastructure. So when they see this, it's like, I can execute my documentation against the system. So it works. It works pretty well. So let's go and run that, and then we'll get on to the more cool stuff. So I usually run Ansible. Not in caps. I usually run. Can everyone see that? Is that right? Or does that need to be a little bit bigger? All right? Yeah? Cool. So I usually run Ansible from a container. The fact being that I'm often addressing storage systems that sit in AWS, running them from AWS on a host within there. So it's nice to have it all packaged up, and we require a single library for this our modules depend on to run. So yeah, I do it that way so I can run it anywhere. I'm actually leveraging our storage provisioner here to attach a volume to the container to store my SSH keys in, rather than storing them in source control or anything crazy like that. And then this container that I'm running is actually made available by NetApp. It's built on a weekly CI/CD process. Just to ensure that it all actually works, and it's got all the latest NetApp libraries in, and obviously the latest version of Ansible. Right, so let's see. So I just got to clone my repository in. I've probably got my password wrong now. Oh no, here we go. Here we go. Cool. Right, so what I've done there, I've obviously got a playbook that calls that role. Go back to my playbooks. There we go. So it calls that role. So it sets up a four node cluster. 4-node storage cluster, and then the NFX NFS export that I create within that, it goes and mounts it to a host as well. It's a bit small, isn't it? So I did actually run it through earlier, just because, I mean, it takes a few seconds to create those storage objects, but too long for this demonstration. I just made a change to the export policy so we can see some different feedback. Yeah, probably not that exciting for most of you in the room, but for our customers, this is really cool. You know, they're like, wow, I can configure my whole storage and my application can consume it within like a couple of minutes. This is great. But so obviously changing hosts now, moving into a different host. I'm creating some groups and some users, which you guys have probably all done this before. I've just put a DFH and then outputted that, so you can see that's the IP address of the interface with the volume, and I've just mounted it from home to user 1. In this role, that's just something I created. If you got an Ansible Galaxy, we've actually done some validated roles that you can download and use. They're probably more concentrated on certain areas of the storage system. This is like okay for my use. You know, it can set up that cluster, but you know, for ongoing sort of enterprise use, you'd probably want to shrink that down to specifics on the system a little bit more, I would say, which is what the ones on Ansible Galaxy do. Right, I'll move on to the Kubernetes stuff now. So I'm going to have 2 clusters here, so that one and that one. So this will be my primary cluster. Let's make this a little bit bigger again than that would do. So you can see I've got a deployment already up. Cool. And then that will have a service with an IP address as well. I've already got it there, look. So that's the Nginx application with persistent storage. So that index.html lives in the persistent storage. I did originally apply for a front-end web developer role, but they didn't give me the job. So now I'm after this stuff. So, right, so if we look on the secondary cluster, just to prove that I'm telling the truth. So there's no resource there in terms of deployment, and there's no persistent volume under there either. Let me type that. So no persistent volume sitting there in that secondary cluster. Now I'll go and show you the playbook that I've written to actually orchestrate this ultimately. So you will notice that there's this gather facts module. So that just goes and gets a load of facts from the system, and it gets a hell of a lot of information. It's I think it's nearly into 1,000 lines of code. And obviously it allows us to use that as variables for later on in the playbook. That was actually written by a guy at Red Hat. I forgot his name. Do you know his name, Mark? No. No, but it's a good example of, community-based effort. Someone noticed that there was a need for this, and I certainly wouldn't been able to do what I'm doing now as effectively without this module. So yeah, really cool that we support that and have rolled it up into the release. Community, way. So I'm going to print them facts out just so you can see how much there is. So then I'm going to be using our Trident, our dynamic storage provisioner. You'll notice I'm just using a shell command because there's actually no modules available for this at the moment. So I'm just executing against the binary. To be honest, up until now, there hasn't been a need for any modules because a lot of that was driven by Kubernetes itself. But with this, it needs to be, at the moment, needs to be driven on the Trident side. So I see a need for modules. So hopefully we may get some in the future. We'll wait and see. But as you can see there, I'm using the variables. So I've used host vars to pass on the variables to the next host, and then I'm getting the volume information there, and I'm finding all of the volume names on the system. But then I've got a when statement in there as a conditional, so it looks for Trident Nginx. So all the volumes are prefixed with Trident, and then Nginx is my deployment. And obviously the reason I need to do this is Kubernetes just gives a random string after that, because all the volumes that you can't specify ultimately. So this would mean I'd have to go and find out the name of the volume in the storage system. It's not a very automated way. So that gather facts module has really helped me out to be able to do this. Then I'm leveraging the K8s module. And what I like about this module is that obviously the way most people address a Kubernetes cluster is using YAML on kubectl. But then, although Kubernetes is a declarative system, the way that you do that is quite procedural. You just use kubectl, create PVC, create deployment, create service. So I find it quite neat to be able to put this into a playbook and define my infrastructure. And it's in the same way, it's a manifest that anyone who understands Kubernetes can also understand. It's YAML, right? So it goes and creates that deployment. And then it creates a service as well, so we can expose this to the outside world. The PVC is actually created by Trident, but we probably haven't got enough time to go into the wheres and the whys of that. So I will go and run that now. That one's not actually in that repo, so I'm actually running it from a host, even though I said I run anything from a container, but there we go. Oh. Cool. So that's a lot of the info that printed there. You can see it's quite a lot of lines. This is me executing my very primitive shell command against a binary, and then going and creating those deployments there. So it's created the deployment, but the service, I didn't actually delete that, so that was already there, but we can see that worked. So now see if we can actually see the application migrated. Obviously I'll do to prove that it's actually there. So what was the... right. So I'm just going for a node pool, so it's 10.6.7.8.9z. And there we go, actually successfully transferred the application with the persistent storage volume underneath it as well. So yeah, I really like the way the sort of three technologies working together. ONTAP, NetApp ONTAP underneath, obviously for the dynamic storage provisioning, Kubernetes, for the application server ultimately, and Ansible as the glue, holding all that together. So it's not anything sort of officially that NetApp have released, but just something I've been working on, something I'm showing my customers, and something they can ultimately see value in. So I think that's probably about time is up now anyway. So thank you very much for listening. And yeah, if you're around later, can have a chat. Have we got time for questions? Yeah. Question or two? Yeah. If anyone's got a question, then give me a shout.
Thanks, Tom. Nice one. Any questions? Shout. You haven't got a mic, have you? No. All right. Can you shout?
You mentioned about NetApp's offering on AWS.
Mm-hmm.
What does that take format? Obviously, it's not necessarily some NetApp filers. What's your sort of play on the AWS space?
Yeah, so it's literally the operating system ONTAP is really sort of now software defined. It's removed away from the underlying controller. It doesn't rely on the controller. So we can deploy it as a virtual machine ultimately within AWS.
Like EBS
and it's using EBS and the back end as block storage. And obviously we can apply all of our deduplication, compression, compaction to actually reduce your footprint, reduce your AWS bill ultimately. We've also can add sort of a caching layer in, SSDs, which will be EBS block there for SSDs. And then obviously the benefit, if you have got an on-prem system, you can use our thin replication protocol, which is called SnapMirror, to replicate between the two, and then just a single API across it as well. So.
Then replication
Yeah, we could do. We do actually do a HA version as well. So you have a machine in two different availability zones. It actually does synchronous replication between that, or you can do asynchronous between on-prem and then into the cloud. Yeah.
Right. Before we turf Tom off the stage, has anybody got a last question?
Cheers, guys. Anyway.